In this video, we're going to talk about how we add and subtract monomials by collecting like terms. So we can simplify a sum or difference of monomials as long as those monomials are what are called like terms. So for example, if I have 7x squared and 11x squared added together, well, both of these terms have a number multiplying x squared. Like it's the exact same variable to the same power. So these are considered like terms. Let me write that a little bit better. They are called like terms. Okay, and when I have like terms, I can think of this as, imagine I have 7 apples and then 11 apples, and I add them together. Well, now I have 18 of them. I have 18 of these x squareds. 18x squareds. Similarly, with this next term, even though there's multiple variables here, and then multiple variables here, well, it's the exact same variables to the exact same powers. So these are also like terms. These are also like terms. Okay, so I have 13 of these x squared y to the fifth, and now I'm subtracting 5 of the x squared y to the fifths. Well, that leaves me with 8 of the x squared y to the fifths. Okay, and then finally, if I changed it ever so slightly, now I notice this second term, the y term has a different exponent than this one does. So even though the x has the exact same power, these are not like terms, unfortunately. They are not like terms. And if they're not like terms, I can't combine them in the same way that I did with these other two examples. Eventually, we'll review how we factor expressions. This can be factored, but we can't just combine it by subtraction directly. Okay, let's do some more practice. Let's simplify the following expressions by collecting like terms. So I have this whole thing minus this whole thing in parentheses. So if I have this minus in front of the parentheses, I can distribute that negative. That'll give me negative 5x squared minus 4x minus 9y, and then minus 6y squared. So now I can see my like terms. I see I get a 7x squared and a minus 5x squared. Those are like terms. There's this plus 13x and the minus 4x. Those are like terms. And then there are these, this minus 5y, 1, 2, 3, minus 9, and minus 9y. Those are like terms. But the minus 6y squared, there's no other y squared term. So that has no like term with it. Okay, so I can combine these x squared ones. 7 minus 5 is 2. 2x squared, and then 13x minus 4x, that becomes plus 9x. Minus 5y minus 9y, that'll be negative 14y. And then the minus 6y squared, there's nothing else with it that it can combine with. So I get this. Okay, part B. So I have some fractions here, and then one term without a fraction, and some square roots floating around. So let's rewrite everything as an exponent. So I got t to the 3/2 over t, which is just t to the 1. Similarly, this t is t to the 1. This square root of t on the bottom becomes a t to the 1/2, as does this square root. So with this first fraction, if you have t to a power divided by t to a power, I get to subtract the powers. So 3/2 minus 1, well, that becomes 1/2 if I get a common denominator. And then with this next term, well, this 3 that's getting multiplied, I can move it to the front. 3. And then t to the 1 divided by t to the 1/2, I subtract the exponents. And 1 minus 1/2 is also 1/2. And then finally, with this last term, I got that 6 in front. Square root of t becomes t to the 1/2. So actually, all of these are like terms. T to the 1/2, another one, and another one. The very first t to the 1/2, the coefficient in front of it's technically a 1. So I have a 1 in front, and then a 3, and then a 6. So if I add those together, I get 10 t to the 1/2. And if I want to write that as a root again, this would become 10 square root of t. And I got it. I could either write it in the exponent form or in the square root form. Okay, part C. So I got 3a squared b plus 4ab squared. So even though both of these terms have the exact same variables, the powers are different. Like this is a squared, and that's just a to the 1. This is a b to the 1, and that's a b squared. So these, unfortunately, are not like terms. They are not like terms, which means I can't simplify them by adding them or subtracting them. I could eventually factor them, but that's not what this problem is asking me to do. It's asking me to collect the like terms if there are any. And here, there aren't any. Okay, so when we have unlike terms like these, we can't combine them by adding or subtracting in the way that we can do when we have like terms. As a final example, something like x squared plus 3x plus 1, well, all three of these are unlike terms. So this cannot be simplified further.